Good morning, friends. Today we will see the next problem, which is in kinetics using second law of Newton. Right. So you can see the problem. I can define it like this. The problem is actually it is on a slope. A body is on a slope and it is connected through a pulley, and you have another pulley connecting that body with, and it is attached to, rigidly it is attached. In the second pulley there will be another body hanging, B is hanging downwards. So body A having a weight of 750 Newton, so the mass will be 76.453 kg. Body B will be 1500 Newton, so the mass will be 152.9 kgs. So what is the problem? What is the acceleration of A and acceleration of B? Because definitely both the acceleration will differ. So if this acceleration AA is having an acceleration of AA, B body B will have an acceleration half of that, because it is connected with two strings. This movement and this movement will be half of that. So the acceleration will be different. First of all, we have to find out whether the body, how to solve this problem. We have to find out whether the body is moving upward or downward. That you have to find it out. So for that, without considering the inertial force, we have to solve the body A for it equilibrium condition. If it is in at rest, what is the frictional force here acting? So I am considering this body. As usual, you know, in the previous frictional module, the slope will be x-axis, perpendicular to that will be y-axis. So the body A is having a weight of 750 Newton, and it is at 30-degree inclination, and this 750 and the tension in this string will be 750 Newton. How this tension is 750 Newton? So body B is, you can see here, body B is 1500 Newton. It is equally distributed in these two strings which is attached on the pulley. Okay, so that is 750 and 750. So this 750 is having a tension here in body A. So that is how we have to find it out. So body A will have a 750 tension, and the normal force will be N acting upward perpendicular to the contact surface, and the weight is acting downward. That weight is inclined, it is not parallel to X or not parallel to Y, so it is inclined 30 degree. So I have to decompose that. The one component will be cos component, the other component, opposite component, will be sine component, 750 sine 30. So I will be solving this. This is a frictional force. Since the body is moving up, we consider the body is moving upward. So the frictional force is acting downward. So we are assuming that the body is at rest. If it is at rest, the frictional force we will consider it as in the negative direction. So we will assume that the frictional force is in the negative direction. So now you will be solving this for equilibrium conditions. While solving this for equilibrium condition, what is the normal force? N is equal to 750 sine 30. It will be 375. Sine 30 is 0.5. So N is equal to 375. Then summation of horizontal forces, if you equate it to 0, so you will be getting 750 minus, sorry, N is equal to 750 cos 30. So N is equal to 750 cos 30. It will be 649.31. So then horizontal forces, if you equate it to 0, it will be 750 minus 750 sine 30, that is 375, minus f is equal to 0. You have two equations. You can see that two equations. So first equation, n is equal to 750 cos 30, it is 649.51 newtons, and second equation is minus 375, that is minus 750 cos sine 30, and this minus F friction and plus 750 is equal to 0. So frictional force will be 375. So what will be the maximum frictional force you have to find out. So the coefficient of friction in this problem is given it as 0.2. So zero point 0.2 into n, what is the normal force? 649. 649 into zero point 0.2, if you calculate, you will be getting it as 129.9. So in this case, you can find out the frictional force what we have assumed, it is more than the maximum frictional force. So what we have assumed, the body is moving upward, that is right. Right. So the frictional force 375 is more than the maximum frictional force, so that the body cannot be at rest, it will be moving upward. So we have found that the body is moving upward, and so that is one case. So the movement of direction we have found out. Then AB, acceleration of B will be is equal to AA by 2, that is 0.5 AA. So two acceleration you have. That is body A you have one acceleration, body B you have one acceleration. That's what we have to find it out. So you can see in the second board, in the pulley, second pulley, in this pulley body B, if I terminate it here, so body B will be like this. It is acting 1500 Newton will be acting, and it is the movement direction of the body B will be downwards. The movement direction of the body will be downwards, and T1 tension 1 will be acting upward. That is on the string. Tension 1 will be acting. So since it is moving downward and it doesn't having contact, there is no frictional force, and since it is moving downward, there will be an upward inertial force you have to substitute. What is that? MB into AB. What is MB? That MB you know, and AB. MB is 152.9, 152.9 into AB. So I can solve it for vertical equation equated to 0. So it will be T1 plus 152.9 AB minus 1500 equal to 0. So my equation, first equation will be T1 plus 76.45 minus 76.45 AA. So AB, I will be substituting it as 0.5 AA. AB, I am substituting it as 0.5 AA. So 152.9 into 0.5 will be 76.45 AA. So T1 plus 76.45 AA minus 1500 equal to 0. That is my first equation. So coming to the, after considering the body B, I have to consider the pulley. This pulley you can see, the pulley downward there will be a tension T1, upward there will be a tension T2. So in this pulley T2, here it will be acting, here it will be acting. Both side you will be, there will be a T2 force will be acting. Here you can see, I can write an equation for this T1 minus T2. So actually it is 2T2 minus T1 equal to 0. I can write it like this: T1 minus 2T2 equal to 0. Both are same. So T1 minus 2T2 are equal to 0. Then coming to the body A. Body A, you can see body A is on an inclined plane. So the inclined line is as x-axis, perpendicular to that as y-axis, and there will be a tension in the body B, that is T2. This T2 will be acting through the pulley, so T2 will be there. Then normal reaction N, downward weight is 750, that I can decompose it as 750 cos 30 and 750 sin 30. And coming to the body A, there will be, body A is moving upward, that we have found it from the first equation. So there will be a frictional force downward. What is that frictional force? It will be 0.2 N. Similarly, to keep the body, since the body is moving, to keep the body in dynamic equilibrium condition, there will be an inertial force I am substituting. that is MA into AA. What is MA? 76.45 into AA. So these are all the conditions. So from this I can find out N. First of all, N is equal to N is equal to 750 cos 30, that is 649.51. 649.51. Then I can equate for horizontal forces equal to 0, that is T2 in the right side minus 750 T2 minus, what is the second one I have written, that is T2 minus 76.45 AA minus zero point 0.2 N minus this force, the decomposed force 750 sine 30, so equal to 0. This I can simplify it. T2 minus 76.45 AA is equal to, if I substitute n value here, this will be a constant, and 750 sine 30 will be a 375, that is also constant. By adding these two, I will be getting a minus constant value, that I am taking it to the right side, that is 504.90. So T2 minus 76.45 AA is equal to 504.90 is my third equation. So I have got three equations. That three equations you can see here. That three equations you can see here. The first equation is T1, and I don't have T2 for the in the first equation. That is 0 T2 plus 76.45 AA is equal to 1500. That is my first equation. Second equation, T1 minus 2T2 equal to 0 we have seen. So T1 minus 2T2 and AA will be 0 here. That is 0 AA equal to 0. That is my second equation. Third equation will be, there is no T1 there. So 0 T1 plus T2 minus 76.45 AA is equal to 504.9. Now I have got three equations. So how many unknowns I have? 1, 2, 3. That is T1, T2 and AA. So 3 unknowns, 3 equations. I can solve it in calculator. So I will get T1 as 1336.6 Newton, T2 as 668.3 Newton, and AA as 2.13 meter per second square. Since AA is 2.13 meter per second square, AB will be half of that. It will be 1.065 meter per second square. This is how you have to solve the problem. So to solve the problem, you have to tackle, first of all, you have to find out the body where it is moving, whether it is moving upward or downward. You have to find out. It is by finding out the frictional force, keeping this body in equilibrium. I will find out the frictional force and the maximum frictional force both. If the frictional force is more than the maximum frictional force, body will be moving upward. That you have to identify. Then you have to solve the body for, first of all you have to take the block B, and then you have to consider, you will get an equation, and you have to consider the pulley, you will have another equation. Then you have to consider block A, you will have another equation. Three equations you will get. We will solve it for three unknowns. We will get the acceleration of body A and acceleration of body B. Thank you.